All right. Okay, here's what I want to talk about today. We're going to do the same kind of idea as yesterday. I'd like you to make your way to bubble.us. And again, bubble has no E on it. Taylor figured that out yesterday. So no E on bubble. So bubbl.us.
So are we making a new one?
Yeah, we're going to make a new one. So now, if you made an account yesterday, that's great. You already have the one from yesterday. You could potentially pull that one back up. It should be in your little like My Maps kind of tab, and you can pull the one up from yesterday. If you didn't have it, because I didn't require that you made an account yesterday, you will need to follow with me and make kind of a chart that has the different shapes on it. If you did not share it with me yesterday, you want to make sure that you did that.
Oh, it's saved on an account.
What?
It's saved on an account.
Really? Seriously?
There it is.
Nice. All right. That saves you a lot of time. A lot of work. All right. That's good. I'm actually really happy about that. If you'd like to, this will be one of the last few days for me for the next couple days that we'll be using this. It was just one of those things I wanted you to see it and to use it and see like the purpose of why it's important to me that you'd actually see something like this. Because I know in like a college classes, they do require that you show outlines and mind maps and brainstorming sessions with groups if you have group activities. And this is one of those things you can do where you can set up a mind map like this, which is free, and you guys can both collaborate on it. Like when you guys shared it with me, because I know some of you did make accounts yesterday, which was fun. When you shared it with me, I can actually make changes to it, and we can both see what happens. We can add to it together. So I thought that was just really kind of a cool concept. And it can be used in just a ton of classes, not just math, because obviously math is probably the most farthest place you'd probably want to use one of these. But what I was thinking about this is like, this is a really good idea to organize thoughts if you're ever doing a proof. We're not doing proofs, by the way, but it was one of those things like, I was just thinking about this yesterday when we were using it, that we could talk about the topic, you know, what the theorem is or the property, and what are all the different aspects we have to talk about? You know, do we have to talk about certain angles, certain walls? You can have those little bubbles, and then we can organize them so they're in a row, and that makes your proof. So we can reorganize it very visual. Now, the big thing about this mind map, using this bubble, you have to use the Chrome browser. We figured that out yesterday. If you try to use like Safari on a Mac or Internet Explorer, whatever the Microsoft one is, it's a Bing. I don't know what the browser is called for Microsoft. It only really works on Chrome. So the Chrome browser, I don't know why, it must be a plugin that it just works correctly. The reason why you saw it yesterday when I was trying to do one of mine, I can't drag the bubbles everywhere like you guys can. Like it doesn't work. It just like, wherever they're at, they're stuck there. And I can't drag it, it doesn't move. So for Chrome, it definitely worked. I tried it in 2 different versions yesterday. I think it works on Firefox too, but those are some of the things I want you to get to. Now, if you wanted to make a count today, you can. Just, if you are gonna make one, make a free one. I'm not requiring it today. But the good thing is you guys all have that bubble, that form that you had. So I'm gonna bring up one of these. This is just one that somebody shared with me yesterday. I just wanna bring it up for you. Let's see. Okay, yeah. Let's download this one. Okay. Okay, here's one that was shared with me yesterday. Okay. This is Brooklyn's from period 3 yesterday. I thought it was really well done, right? She had the polygon, the definition, she had the quad, she had the major types of quads, which are parallelograms, trapezoids, kites. These are the 2 I want to talk about today, because I know like a lot of you are like, we don't have the definition of kite yet, or we haven't really discussed it. That's what I want to talk about today. I want to see if we can get to those 2. We had an Isosceles Trapezoid. These 2 we've had, but it was a couple weeks ago. And then these other ones you should have had, and I just like the way that she did it. It's very clean, very pretty. That's something you should have had yesterday, and you should have shared it with me in some form, fashion. I don't care how you did it. If you wanted to make an account, you could click that little triangle of arrows up in the top corner there. It would share it with me. If you took a screenshot, it's fine. This is one of the screenshots that somebody shared with me. It was just, that's what I was looking for. Today, the good news is, like you guys are saying, like it's still there, correct? Yeah. Everyone still has one? Perfect. Here's what I would like to do today. Underneath these, and I'll give you the page numbers here in a minute. I would like you, if you can, to fill in some more bubbles. So I'd like you to have bubbles off of these. So now, obviously for trapezoid and kite, we don't have any yet. We're gonna see those today. But off of these, I want you to make more bubbles off a parallelogram today. And I want you to, these bubbles I want you to make, I would like you to put the properties we've talked about, the theorems. Like the specific theorems we've discussed. Now, you're probably thinking, God, we've had a lot of theorems. I'm gonna specifically give you the pages I want you to pull from. And all I want you to do is, like, let's say we're gonna do the parallelogram. I'll give you one right now. So let's say we're gonna do the parallelogram. You're gonna make your first bubble, okay, off of a parallelogram. And again, you'd wanna click the bubble, like the plus sign down below it. You can drag this anywhere you want. One of the first theorems we talked about for a parallelogram was theorem 6.3. And that was the opposite sides are equal. And I want you just to paraphrase what those theorems said. Okay, that paraphrasing means you're not using the exact wording. You don't need to copy paste it. I want you just to write down what you know that thing meant. You know, like the opposite walls are equal. And one of the theorems was the diagonals bisected each other. That type of thing. I want you to make the bubbles for each of the theorems. Now here's the page numbers. If you're stressed, you're like, oh my gosh, I don't even remember the page numbers, let alone what we're doing here. Here's the sections we've actually covered. Let's see. Let me let's see if I can not have this in full screen. Alright. Okay, so it's not full screen. Hopefully this will work now. Alright, so again, you're typing those theorems. Here's the page numbers you can pull from. So section 6.1 was page 393. I'll make this bigger here in a minute. 6.2 was 403. Section 6.4 was 423, and section 6.5 was 430. These are the only sections we've actually covered. So that's where your theorems are going to be found, the properties. And I want you to put them in there. Now, some of these shapes should have like a generic formula that works for all of them. Like for instance, there in that first section, 6.1, there was properties that applied to all polygons. So that shape, the polygon bubble, should have its own select formulas. I think we had 3 formulas we talked about in section 6.1: interior angles, exterior, and diagonals. So you should have 3 bubbles coming off of this thing with properties. You're going to try to fill in the properties we've discussed in class. You can use your notes, you can actually use the online version of the book, but I want you to put your properties and make bubbles. You are going to try to share this with me one more time. So I would almost recommend today that you almost make an account today before we get started. You can make it as you're working, obviously, because it did save it, so that's kind of nice. The reason why is that this one will take you longer. The reason why we're doing this is this is supposed to be a helpful review of what our theorems are before we get to practice test days.
Are we supposed to do theorem 6.3 or what?
6.3, 6.4, 6.5. All the theorems we have up to this point were through 620, but there was about 5 or 6 in the middle we never covered because we didn't go to section 6.3. So there was a big chunk in the middle we never covered. So, question.
We still have this. So we can use
Yep, you can still use that. So yeah, if you didn't see that, hold that up there, Nelson. That little like pamphlet thing we had that we made, that little graphic organizer, that was one of the reasons why I had you make that, is because you can use it on this as well. And you can fill those properties. Now, when you make your bubbles, you have to have them attached to the correct shape that we're discussing. So if the property talks about generic parallelograms, you better have it talking about this box. If it talked about all polygons, you have it attached to that box. If it was just properties about rhombuses, it's better to be attached to this box. Here's the good news, and this is something I didn't talk about yesterday. You can actually make random bubbles without having to click a lot of plus signs. Because, yeah, you just double click anywhere in the free space. You just like take your mouse, you double click down here, and suddenly it'll just make a bubble and allow you to type in it. Then you can attach arrows later to it. That's what I would probably do. But again, use Chrome. That's the only one that you can use right now because you're on a Chromebook. But I would like you to fill in those properties. I'm going to give you, I don't know, maybe another 5 minutes, 10 minutes to get started. This is something that it's not due tomorrow, it's not due today. This is something I want you to work on for the next couple days in here because I want to use this for test day. So if this might be something you want to make an account so you can save it, because on practice test day, we have a lot of vocab in the vocab banks, and a lot of them are theorems. And nothing's worse than going, I don't remember what theorem 6.4 is. Even though it had a name, right? It was called the opposite angles theorem. I don't remember what it is. You could have this up beside you and go, oh, this is what the theorem said. Like this is what it talked about, how to use it. I'm going to tell you right now, in this chapter, chapter 6, we didn't do hardly any proofs. So I would not expect that on the test. I'd be expecting problems where you're solving for x and y, you're finding numbers bouncing around pictures, you're finding, angles or, number of diagonals. Like that's the type of stuff that you should be expecting. And again, I'm going to try to hand out your practice guide as early as tomorrow. I don't know if we'll necessarily start reviewing tomorrow. Now, again, tomorrow, just a heads up, we are gonna have a new scene chart tomorrow, just because the test is coming up and I want you to do your scene chart, and we know how the scene works for testing. I always move the desks around. The other thing is that I don't know if it's tomorrow or Monday. One of those days, Mr. Hegg will be in here at some point observing. That's not you; he's observing me. I don't know if it's your class or if it's period 3 or if it's period 5, 7, or 8. It's one of the geometry classes he's coming in to kind of view. I'm just giving you a heads up, if he's in here, don't be thrown off by it. He's actually watching me. So, just kind of have a heads up on that one. But I'll give you another 5 minutes or so. We're in here until 11:15, then we have period 5 today. So we have a little bit of time here. But this is something I want you to start working on, and over the next couple days, kind of fill in some of those theorems. Again, the theorems you should have, I think it's 6.3 to 6.8. We had theorem 6.1 and 6.2 obviously, but theorem 6.3 to 6.8, and then I think we jumped to 6.13 through 20. There was a big chunk in the middle we never talked about. There was 5-ish in the middle we never discussed. But we're not done yet, right? We still have to talk about trapezoids and kites today, and I want to get through those definitions today. So that's why maybe 5 minutes we're going to go through those definitions. And then you can make sure that on this chart, did you have the right definition given to you? Maybe another 2 or 3 minutes here. And again, as recommended, I'd probably almost strongly recommend that you make an account for this, just because maybe over the next couple days you're going to be adding to this. But it's not due, so don't feel like you have to share it with me right now. I'll kind of fill you in when we're going to need this. This is hopefully to help you organize your properties and definitions and all that. So the most common thing people struggle with right now is vocab. Hopefully this will help you with vocab. If you'd like to just have your notes off to the side, I want you to take out your notes, like your actual paper notes, not your online mind map here. I want to talk about a few of the definitions. This is something where if you have your Chromebook open, you can kind of compare it to what you wrote yesterday for the definitions. I want to talk about the trapezoid and kites today, but I need to get rid of the lights here because it's going to get a little difficult to see. If any of you can't see it, apologies. We'll probably do for the major notes we're going to do tomorrow, I'll probably go back to the Nearpod idea tomorrow, so just kind of be aware of that. You will need your Chromebooks tomorrow, because some people really like that. They like to have the notes in front of them, they don't have to wait for me to click, and we'll try out some problems with that. And there's some, I looked back through some of the notes that you guys had with Mrs. Edwards, things that we're very comfortable with, things that we're not comfortable with in terms of math right now. Most common problems that I saw a lot of questions were on was SOHCAHTOA problems, the trig functions, and Pythagorean theorem problems. That might be something in the notes tomorrow. We'll kind of start reviewing that again, because we do need those. But remember, a majority of the notes tomorrow will be on these. This is where a majority of our stuff will be on tomorrow. Well, we'll do a couple other things. Alright, questions, comments about what we're doing here? Okay, we got about 5 minutes. I want to go through just a few definitions. So, goals today. Let's go through the definition of what a trapezoid is and the other vocab words that are involved with a trapezoid. What I mean by that is that there's isosceles trapezoid, like the second one. I want to go through those two definitions. There's a bunch of properties which we're going to start tomorrow with the Nearpod with the trapezoid. There's a few theorems. They're all pretty much the same type. Some about angles or a certain wall on a trapezoid. So there's only a select few things we can do. We'll try to do a bunch of examples tomorrow to make sure that you understand how trapezoids work and what I'm going to ask of you with a trapezoid. And then Monday we'll continue with that. Okay. And then today I also want to introduce the kites today and give you the definition because we haven't actually had that word yet. What a kite is. I've vaguely said that there's this random third type, but we haven't got to it. And we'll talk about the vocab. And then Monday we'll probably see the theorems on those. We probably won't see those tomorrow. This will be something I'll save for Monday. And then we'll start reviewing after that. So we're probably not looking at the test until the end of next week, maybe Wednesday, Thursday, Friday time. Because again, I just said it was tentative when we're going to actually do the test. All right, are we good? All right, here we go. Let's jump right in. Let's talk about this definition. Definition of a trapezoid. It is a quad with exactly one pair of parallel sides. So if you're checking your if you're checking that little mind map thing, the bubble, this is probably what you had. I know a lot of people just use Google. Some people actually went in their textbook and actually searched it. But this is the definition of a trapezoid. One pair of sides are parallel. Let me give you a picture of it here. Here it is. One pair of parallel sides. So on this particular picture, do you see the little pink arrows? Okay, these pink arrows, those are the walls that are parallel. The other two are not. Now, on a random trapezoid, the walls that are actually parallel are called the bases. It doesn't even matter if they're going up or down or right and left like this picture is. Whatever walls are parallel, those are the bases. Then the legs are the two walls that are going to taper together. They're actually going to connect. So if I were to continue AD here, in this path, and then connect BC, they'll meet up here, so these are the legs, because they'll eventually meet. They're tapered together. But there's only one pair of sides that are parallel. Now there is such a thing as called base angles and whatnot. Bases, again, parallel sides, legs are the non-parallel, but base angles are the angles that are formed at the corners of a base and a leg. So in this picture, there is 4 base angles. There's, didn't mean to get rid of that. There is the angle D here, that's a base angle because it meets a base and a leg. There's angle C, that's a base angle. There's angle B and angle A. All 4 of these are base angles because they meet in the corners where a base and a leg would meet. Now, what we'll eventually talk about is on this picture, certain angles are equal to each other. And that's something we're eventually going to get. In certain cases, there is actually angles that are equal. In certain cases, I should say. Not every case, certain cases. Okay. Any questions on what a trapezoid is? Can I click to the next slide? We good? Okay. The isosceles trapezoid is basically the exact same definition. It just has one extra part. So it's still, it's still a quad, has one pair of parallel sides, but here's the new thing. The other pair of sides, the ones that are not parallel, those walls that are not parallel, those are equal in length. They're actually congruent. So here's my picture. So it's the same picture I just showed you, but if it's isosceles, the legs are actually equal to each other. The bases aren't, but the legs are, because the bases are parallel. The other pair are equal. So, bless you. So, pair of parallel sides, you have a pair of congruent walls that are not parallel, and you still have base angles. So it's the exact same picture. Again, why I'm giving you this, because I want you to check your little mind map thing to make sure that maybe you filled those in. You didn't have to, but maybe you did. Did you fill it in right? Parallel sides, and you have another pair that are equal. Good. Isosceles trapezoid. Some people didn't fill that one in, that's fine. It wasn't a crucial one yet. We hadn't talked about it for a while. I was really looking at, did you have all the parallelograms filled in? All right, any questions with the isosceles trapezoid? Is everyone good with it though? Everyone's got it? Okay, last word today. I think we only have about 30 seconds left here, so if we don't get to this one, that's fine, we'll finish it tomorrow. It's a kite. We haven't talked about the definition of a kite. A kite is a quad, still a quad, generic quad, so it's not a parallelogram or anything like that, but it has two pair of consecutive walls that are equal. Now you're thinking, I know a lot of people look at that and go like, whoa, that looked like one of the theorems we had the other day. It was like Theorem 619. It said certain walls are consecutive that are equal, then it's a rhombus. This one says it has two pair of them. Two pair of consecutive walls are equal, like this. This is a kite. Two pair of walls are equal that are side by side. It has two pair. They don't all four have to be equal, so it's not a rhombus. Only these two are equal, and then the other two. And that's what makes a kite. Two of the walls are actually longer. It gets more air space. It has more area to collect wind. Questions on any of the definitions today? Perfect. All right, over the next couple days, work on getting those theorems filled in on that mind map. And if you can make an account, do that. Yes. Oh, yeah. We have started the fourth quarter, so you're good. I'll just fill it out. So.
Ward. Mind maps.
What was that?
What does mind maps do?
Just that one, just the one that we did yesterday with the definitions. You just submit that when you get all the definitions written in there. This one with the theorems, that'll be a later date. So I'm not worried about it right now.
When do you want me to get that yellow sheet done?
Monday. By Monday.